Good day, everyone. I am Princess Diane Orbita, your presenter for today. And in our Math Sub M1 History of Mathematics, I am going to discuss the Greek mathematics and mathematicians. To begin, Greek mathematics refers to mathematics texts written during the idea stemming from the Archaic period through Hellenistic and Roman periods. By the Hellenistic period, the Greeks had presided over one of the most dramatic and important revolutions in mathematical thought of all time. The Attic or Herodianic numerals. It is a symbolic number notation used by the ancient Greeks. They were also known as Herodianic numerals because they were first described in 2nd century manuscript by Herodians. It is also a base 10 system.
The Thales-intercept theorem. Thales is one of the 7 sages of ancient Greece who lived on the Ionian coast of Asia Minor in the first half of the 6th century BCE. He credited with another theorem, also known as Thales' theorem or the intercept theorem. The intercept theorem is also known as Thales' theorem, basic proportionality theorem, or the side splitter theorem, is an important theorem in elementary geometry about the ratios of various line segments that are created if two intersecting lines are intercepted by a pair of parallels. The legend of the 6th century BCE mathematician is Pythagoras of Samos. He has become synonymous with the birth of Greek mathematics. He believed to have coined both the words philosophy, the love of wisdom, and mathematics, that which is learned. He is the first to realize that a complete system of mathematics can be constructed. Pythagoras' theorem, or the Pythagorean theorem, is one of the best known of all mathematical theorems. There are 3 geometrical problems that were also referred to as the 3 classical problems, and also be solved by purely geometric means, using only a straight edge and a compass, date back to the early days of Greek geometry. The 3 classical problems are squaring the circle, doubling the cube, and trisecting the angle. Next is Hippocrates of Chios. He is one such Greek mathematician who applied himself to these problems. His contribution to the squaring the circle problem is known as the Loon of Hippocrates. His influential book, which is The Elements, was the first compilation of the elements of geometry, and his work was an important source for Euclid's later work. Zeno's paradox of Achilles and the tortoise. It was the Greeks who first grappled with the idea of infinity, such as described in the well-known paradoxes attributed to the philosopher Zeno of Elea in the 5th century BCE. The most famous of his paradoxes is that of Achilles and the tortoise. Based on the picture shown, it describes a theoretical race between Achilles and a tortoise. Achilles gives the much slower tortoise a head start, but by the time Achilles reaches the tortoise starting point, the tortoise has already moved ahead. By the time Achilles reaches that point, the tortoise has moved on again, etc. and etc. So that in principle, the swift Achilles can never catch up with the slow tortoise. Next is Zeno's so-called dichotomy paradox, are based on the infinite divisibility of space and time, and rest on the idea that a half plus a quarter plus an eighth plus 16th, etc. to infinity will never quite equal a whole. Aristotle was the first of many to try to disprove the paradoxes, particularly
as he was a firm believer that infinity could only never be potential and not real. Next is Democritus. Democritus is the most famous for his present ideas about all matter being composed of tiny atoms. He is a pioneer of mathematics and geometry in the 5th to 4th century BCE. He produced works with titles like On Numbers, On Geometrics, On Tangencies, On Mapping, and On Irrationals. Although these works have not survived, we do know that he was among the first to observe that a cone or a pyramid has one-third the volume of a cylinder or a prism, with the same base and height, and he is perhaps the first to have seriously considered the division of objects into an infinite number of cross-sections. Plato is the mathematician that were best known for his description of the 5 Platonic solids, but the value of his work as a teacher and popularizer of mathematics can't be overstated. Next is Eudoxus of Cnidus. He is usually credited with the first implementation of the method of exhaustion that were later developed by Archimedes. It is an early method of integration of successive approximations which he used for the calculation of the value of the pyramid and cone. He also developed a general theory of proportion, which was applicable to incommensurable or irrational magnitudes cannot be expressed as a ratio of two whole numbers, as well as to commensurable or rational magnitudes, thus extending Pythagoras' incomplete ideas. Older cultures, like the Egyptians and the Babylonians, have relied on inductive reasoning, that is, using repeated observations to establish rules of thumb. It is this concept of proof that gives mathematics its power and ensures that proven theories are as true today as they were 2,000 years ago, and which laid the foundations for the systematic approach to mathematics of Euclid and those who came after him. That's all for today. Thank you and keep safe, everyone.